Okay, let's see how to solve this problem. The problem was if it takes 2 seconds to raise an 8-kilogram block, a vertical height of 1 meter, what is the power output? So we know the time that it takes, we know the mass of the block, and we know how high the block is going to be raised. So the question is, how much power will be used? We know powers work over time. I don't know what the work is. They did not give it to me. So work is going to be equal to force times the distance. In this case, I don't know how much force is applied, but I do know the force is going to be equal to the weight of the object, which is going to be the relationship F is equal to m, which is the mass, times g, which is the gravitational constant. So I plug my values in. Well, F is equal to 8 kilograms times 9.8 meters per second squared, which is the constant for gravitation, which would be given to you on an equation, on an exam. My answer comes out to be 78.4 newtons. This will be the F, the force, in the previous equation that has work is equal to force times distance. So going back to that relationship, I say work is equal to 78.4 newtons. I just calculated what the force would be, times the distance that it's moved, which is 1 meter. It gives me an answer of 78.4 joules. Now that I know what the work, how much work is done, I can go back and use my equation for power. So power is going to be equal to 78.4 joules divided by the 2 seconds that it takes to raise this block. The amount of power outputted will be 39.2 watts. Now we'll check for significant figures, and it's easier to write my answer in scientific notation, which is 4 times 10 to the 1 watts is how much power is put out.